Don't know, sir. I just joined.
No. Yesterday you was absent now.
Oh, yes, sir. I was absent.
So have you gone through the video, ma? It's in free time.
No, sir, I haven't. I'm having pre-post right now.
Okay. So yesterday we completed the preparation of the alcohols completely. So anyway, you join, na? So I think so still somebody they didn't join here. Until that briefly I can explain to you. Okay, what we discussed in yesterday class. So in yesterday class, what we discussed means here. So we discussed about preparation of the alcohols from carbonyl compounds only. Okay. In that also, how we are going to prepare the alcohols from the carbonyl compounds. Actually, we had seen two methods. So one is the reduction reaction. If the carbonyl compounds are, it undergoes to the reduction reaction means it forms as a alcohols. Okay. And based on that, there is a one step here. And at what is the another step means here, when the aldehydes carbonyl compounds are treated with Grignard reagent. What is the Grignard reagent, Samhita?
MGX.
RMGX. Okay. So RMGX is called as a Grignard reagent. Okay. Now let us see. First, I had given us some example. When the formaldehyde is reacts with Grignard reagent means it forms Grignard reagent and it undergoes to the hydrolysis reaction means finally it forms as an alcohol. So formaldehyde it forms as a primary alcohol. Acetaldehyde it forms as a secondary alcohol. Acetone, ketones are they form as a tertiary alcohol. So this is the one step we discussed here yesterday and clearly with mechanism completely explained and we solved some questions also. Okay, we solved some JEE level, NEET level questions also we solved here. Okay, after that, so clearly some exception cases that in NEET level and JEE level they're asking here. So which of the following carbonyl it forms as a only primary alcohols? We have a only one answer, that is the formaldehyde. Formaldehyde only it forms as here primary alcohol. Okay, so prime formaldehyde only it forms as a primary alcohol. Other aldehydes are they give as a secondary alcohols and ketones are they form as a tertiary alcohol. This is the conclusion about the reaction with Grignard reagent. Okay, and ethers. Ethers. 1 second, just I'll drop a message. Sorry for the late. Right, and from ethers also it undergoes the hydrolysis reaction means it forms as a alcohols. Here we have two types of the alcohol. Symmetrical ethers are two types of the ethers are there. One is the symmetrical ethers, another one is unsymmetrical ethers. So when you take as a symmetrical ethers means you will get as a same product only. Okay, you will get as a same product. And when you take unsymmetrical ethers, so when you are going to take as a unsymmetrical ethers, so what is the example for the symmetrical and unsymmetrical means? The symmetrical dimethyl ether is it undergoes to the hydrolysis reaction, it forms as a methanol. Okay, and if unsymmetrical ether, what is the example of the unsymmetrical ether means here? Ethyl methyl ether. If the ethyl methyl ether is going to be converted into ethanol and methanol, methanol and ethanol. So mixture of alcohols can be separated by the distillation method. Mixture of alcohols can be separated by distillation method. And what is another method we are using in the preparation of the alcohols means here esters. When the esters are it undergoes the hydrolysis reaction also, it forms as a carboxylic acid as well as methanol is going to be formed. Okay, so what are the products it is going to form means here? So carboxy esters are undergoes to the hydrolysis reaction means it forms as a carboxylic acid as well as esters it is going to be. For that one, some examples we already done. Okay, now today we will discuss about the preparation of the phenol. Okay, so first we'll discuss about the preparation of the phenol. Otherwise, shall I complete the alcohols part completely? Can I complete alcohols?
Preparation, sir.
Ma?
Preparation of phenols, we can start.
Preparation of phenols, can I start?
Yes.
Aditi? Right, ma?
Yeah, sure.
No. So all preparations you want to study at one place only, yeah? Then fine. Preparation of phenol. Preparation of phenol. Preparation of phenol here. So how are you going to prepare the phenol? Actually, what is meant by the phenol here? On benzene ring, if the OH group is there, means that we can call as a phenol. Okay, the name of the phenol is accepted by the IUPAC also. Okay, the name of the phenol is accepted by IUPAC. Okay, and these also we can call phenol, also we can call as a carbolic acid. Phenol also we can call as here carbolic acid. Okay, now, so how we are going to prepare the phenol? How we are going to prepare as a phenol means here, first dose process. We have a dose process. Dose process. From the dose process also we can prepare as a phenol. Okay, sir, how we can prepare as a phenol means dose process. Sir, what is meant by the dose process means here, when here chlorobenzene is treated with sodium hydroxide. Okay, so chlorobenzene is treated with sodium hydroxide at 300 degrees Celsius and 200 atmosphere pressure. Okay, at 200 atmosphere pressure and 300 degrees Celsius, chlorobenzene is reacts with the sodium hydroxide. First, it forms as a sodium phenoxide. Okay, it converts the sodium phenoxide. So this reaction is nucleophilic substitution reaction. So nucleophilic substitution reactions are, is any possibility is there to take at room temperature? Is any possibility is there to take the nucleophilic substitution reactions at room temperature?
No, has to be high temperature.
No, sir, here. At normal temperature, haloarine, sir, it does not undergo the nucleophilic substitution reaction. So when they undergoes the nucleophilic substitution reaction means when the haloarines are attached with more number of electron withdrawing groups. If it is attached with the more number of electron withdrawing groups, then the reactivity is going to be increases. Then it undergoes the nucleophilic substitution reaction. But in this one, haloarines are treated with the sodium hydroxide. It follows the nucleophilic substitution reaction. Okay, the reaction is carried out 300 degrees Celsius. Okay, so that's why chlorine is replaced by ONA plus HCl is the product. Byproduct is HCl. Again, whatever the NaCl it is formed, that it is treated with the HCl. Okay, that is treated with here hydrochloric acid. If it is treated with the hydrochloric acid means here, in this one, Na is replaced by H and byproduct is it forms as a NaCl. Byproduct it forms as a NaCl. So the given reaction is called as a dose process. Sir, what is meant by the dose process means chlorobenzene is reacts with the sodium hydroxide at 300 degrees Celsius and 200 atmospheric pressure. It forms as a phenol. Got it? Next. Next one. So what is the next one means here? An oxidation reaction. From oxidation reaction. Oxidation reaction. So from oxidation reaction also we can prepare as a phenol. By oxidation reaction also we can prepare as a phenol. So how we can prepare means here, when benzene is, it undergoes to the oxidation reaction, half mole of the O2 in presence of vanadium pentoxide V2O5 at 300 degrees Celsius. Okay, at 300 degrees Celsius. When the benzene is reacts with the half mole of oxygen in presence of V2O5. V2O5 act as an oxidizing agent. Act as a oxidizing agent. So when it is treated with in presence of V2O5 means it forms as a phenol. It forms as a phenol. So this is the one method. Okay. And what is the another method we are having means here? From first Benzene reacts with the oleum or from the benzene sulfonic acid. From benzene sulfonic acid. From benzene sulfonic acid. So from benzene sulfonic acid also we can prepare as a phenol. So how we can prepare means first benzene sulfonic acid is it undergoes to the basic hydrolysis reaction SO3H. So what is the molecular formula of the benzene sulfonic acid means here benzene SO3H. So first it is treated with the NaOH. If it is treated with the NaOH means it forms as a sodium benzene sulfonate. Forms as a SO3Na. Again it undergoes to the hydrolysis reaction. H2. Again, it undergoes to the hydrolysis reaction means it forms as a sodium bisulfide and OH plus NaHSO3 is going to be formed. Clear? So when benzene sulfonic acid is treated with the sodium hydroxide, first it forms as a benzene sodium benzene sulfonate is going to be formed. Again, it undergoes to the hydrolysis reaction means it forms as a phenol plus sodium bisulfide. Sulfite is different, sulfate is different. Now only I'm telling that. Okay. What is the molecular, what is the ionic formation of the sulfate? What is the ionic formation of the sulfate, ma? What is the sulfate formation, ma? Ionic formation of the sulfate. SO4 2 minus. Sulfite is called as here SO3 2 minus. Okay, now you got the clarity. This we can call as a sodium bisulfite. This we can call as a sodium bisulfite. Okay, and we can go for the another step. So what is the another step means here? In this one, from benzene diazonium salt. Any one of you can you tell me the benzene diazonium salt? What is the molecular formula of the benzene diazonium salt? From benzene diazonium salt. Diazonium salt. On benzene ring N2Cl plus Cl minus. This we can call as a benzene diazonium chloride. Benzene diazonium chloride. Now, how are you going to prepare the benzene diazonium chloride? We have some name reactions. So, where we studied this reaction means in haloarenes chapter. Preparation of the haloarenes. Haloarenes also we prepare from the benzene diazonium salt. So how we are going to prepare as a benzene diazonium salt and what is the name of the reaction? That is my question. Any one of you? Aditi, do you have any idea? Samhita, Ritu?
Sir, can you explain?
What is the name of the reaction in the preparation of the benzene diazonium salt?
Sandwich reaction.
Very good, Samhita. Sand-Meyer reaction. What is the name of the reaction means here? Sand-Meyer reaction. In Sand-Meyer reaction, what we are doing, Samhita? How we are going to convert
So
the
we take benzene with NO2 group and then react it with NaNO2, I think.
then
No, one second.
yeah, actually it's not the reaction here. So I'll write clear full reaction here, Sandmeyer reaction. We are not taking as a benzene. That is a full lengthy process. You are telling that. Actually, Sandmeyer reaction is reactant. We are taking as a aniline. So which we can call as aniline. What is meant by the aniline? On benzene ring, if NH2 group it is, that means that we can call as a aniline. Aniline is treated with sodium nitrite NaNO2 in presence of HCl at 0 to 5 degrees centigrade. If 0 to 5 degrees centigrade means that amine functional group is converted into the diazonium. Diazonium means N2Cl minus. This one is N2 plus. Okay, so this we can call as a benzene diazonium salt. When the benzene diazonium salt is warmed with water, warmed with water. If you warm means here, it is converted into phenol. It forms as a phenol. OH. In this one, nitrogen gas is going to be released to the atmospheric air and water molecule is the byproduct. Okay, it forms as a phenol when the benzene diazonium salt is warmed with water. Warmed with water means it forms as a phenol and releases the dinitrogen gas in the atmospheric air, and byproduct is water molecule. Clear? Next, another method. So what is the another method we are using here? From salicylic acid. From salicylic acid. Salicylic acid. So any one of you can tell me the structure of the salicylic acid? So this we can call as a salicylic acid. So this we can call as a salicylic acid. So when the salicylic acid is treated with sodium hydroxide, first the salicylic acid is treated with sodium hydroxide. If it is treated with the sodium hydroxide means it forms as a sodium salicylate. So what is the reaction intermediate forms means here? It forms as a sodium salicylate. So this we can call as a sodium salicylate. Sodium salicylate. Again, sodium salicylate is treated with soda lime. It is treated with soda lime. So what is the molecular formula of the soda lime, which we can call as a soda lime?
CaCO3?
That's not the soda lime, that is the limestone. What is meant by the soda lime?
Sir, NaOH,
Very good, ma. It is a mixture of sodium hydroxide. It is a mixture of NaOH and CaO. It is a mixture of sodium hydroxide and calcium oxide is called as a soda lime. So what is meant by the soda lime means here? Soda lime is the mixture of sodium hydroxide and calcium oxide is called as a soda lime. Okay. So why we are using as a soda lime? Ma? Soda lime is used as a decarboxylating agent. Soda lime is used as a decarboxylating agent. So that means NaO and this COONA, it comes outside in the form of Na2CO3, and this hydrogen is going to be attached to benzene ring. If it is attached to the benzene ring means it forms phenol. It forms phenol. So now you got the clarity here. Okay, by the decarboxylation, that means when from salicylic acid also we can prepare as a phenol. Okay, from salicylic acid also we can prepare as a phenol. So what are the methods we had seen, ma? From benzene diazonium salts also we had seen oxidation of the benzene. Okay, and Dow's process also we had seen. Other than that, if you're having any methods, 1 second, ma. What are the other methods we are having, ma? Actually, we are using these methods in the preparation of phenols, ma, here. Okay. Next, if any other methods are there means. Right, ma. These are the methods we are using in the preparation of phenols. So then, what are the properties, ma? So now we can check it out, the properties of physical properties of the alcohols. Do you have any idea about the properties of the alcohols? Properties of the alcohols, any one of you? Properties. First one, lower alcohols are colorless liquid. Lower alcohols are colorless liquids. Colorless liquids. Okay. And some alcohols are having some characteristic smell. Some alcohols are having some characteristic smell. Okay. And in this one, is alcohols are soluble in water or insoluble in water, ma? Any one of you? Is alcohols are soluble in water or insoluble in water?
Soluble, sir.
Soluble. How are you telling that low alcohols are soluble in water?
It is due to their ability to like form hydrogen bonds with the
Very
water molecules.
here, lower alcohols are highly soluble in a water. Okay, so remaining here, higher alcohols are we can call as a solids. Higher alcohols are they become as a solids. Okay, in this one here, lower alcohols are highly soluble in water. Here, alcohols are highly soluble in water. Highly soluble in water. So why they are highly soluble in water means due to the presence of intermolecular hydrogen bonding. Due to the presence of intermolecular hydrogen bonding. Okay, so due to the presence of the intermolecular hydrogen bonding, if the carbon chain length is increases, if carbon chain length is increases, solubility also is going to be decreases. Solubility also decreases. Okay, the carbon chain length is going to be increases means their solubility also is going to be increases. Sir, what happens if the carbon chain length is going to be increases, solubility is going to be decreases means because of covalent character is going to be increases. That one simple example. So what is the example we can take means here? For example, methanol, ethanol, propanol it is there. Okay, I'm taking as a ethanol, propanol, CH3 bond, CH2 bond, CH2OH, and ethanol we can say. So what is with ethanol means here? C2H5OH and methanol CH3OH. So which one is highly soluble in the water? Methanol, ethanol, propanol. So which one is highly soluble in a water, ma? Any one of you?
Propanol?
Now only I told that. Carbon chain length, here only statement is there. If the carbon chain length is
Oh,
increased,
sorry.
solubility also is going to be
SCOH.
decreases. So which one is more highly soluble in the water? Methanol, CH3OH is highly soluble in the water. Sir, how you're telling that means in the first one we have only one carbon atom. Second one we have a two carbon atoms. Propanol we have a three carbon atoms. If the carbon chain length is going to be increases, their solubility also is going to be decreases because of covalent character is going to be increases. If the covalent character is going to be increases, the solubility also is going to be decreases. Now you got the clarity, all of you? All of you got it here? Got the clarity or not, ma? Then what about the boiling point temperatures? So boiling point temperatures, BP. So boiling point temperatures. Now here I am asking one question. If you compare with the hydrocarbons, okay, aldehydes, morning only I had seen some question. Aldehydes, alcohols, and ethers. Okay, can you write the increasing order of boiling point temperatures of the following compounds? Right, the boiling point temperatures of the following compounds. Which one is having the high boiling point temperature while having the similar molecular mass? If the hydrocarbons also having same molecular mass, aldehydes, alcohols, ethers, all are having same molecular mass. Okay, if they are having same molecular mass, means which one is having the high boiling point temperature? So this question morning I had seen some. I'm verifying some JEE papers, previous JEE papers, 2022 JEE papers. In that one, it is that this question. 2022. Write the increasing order of the boiling point of the following substances. That is the question.
Sir, alcohols have the highest boiling point.
Okay. After that,
Then ethers.
ethers or aldehydes, ma? Once you check it out. Alcohols is correct.
Aldehydes, ethers, and then hydrocarbons.
Very good, Samhita. So first, which one is having the high boiling point temperature? Means here, alcohols are having high boiling point temperature. After that, aldehydes. Okay. After that, aldehydes. After that, ethers. After that, ethers. After that, hydrocarbons. After that, hydrocarbons. Okay. Now you check it out here. So here, sir, why the alcohols are having high boiling point temperature means here because of so why they're having the high boiling point temperature means because of alcohols are they involves the formation of the intermolecular hydrogen bonding. First of all, can you tell me the clarity here? How many members we are having idea about the hydrogen bonding? How many types of the hydrogen bonds we are having? What are the types of the hydrogen bonds? Types of hydrogen bonds. Any one of you? Aditi, how many types of the hydrogen bonds are there? Aditi, I think so you are going to write the test based on this concept this year. The question is related to chemical bonding. I'm giving a hint also. In chemical bonding, we are going to study about the types of bond. We are going to study about the ionic bond, covalent bond, coordination.
So can you repeat again the question?
What are the types of the hydrogen bonds?
So intermolecular and intramolecular.
Very good, ma. So intermolecular and intramolecular. What is by the intermolecular hydrogen
Sir,
bonding?
intermolecular is between two different compounds, like
Okay. Then what about
hydrogen.
the intramolecular?
Intramolecular bond is within the compound.
Very good, ma. So actually we have two types of the hydrogen bonds. What are the two types of the hydrogen bonds we are having means one is intramolecular hydrogen bonding, another one is intermolecular hydrogen bonding. Okay, so intramolecular hydrogen bonding means if the hydrogen bonding is present within a molecule is called as a intramolecular hydrogen bonding. Okay, if the hydrogen bond is present in between two different molecules is called as a intermolecular hydrogen bonding. Okay, due to the presence of the intermolecular hydrogen bonding, okay, due to the presence of the intermolecular hydrogen bonding, their melting points and boiling points also is going to be increases, and their solubility also is going to be increases. That means solubility is depends upon the number of hydrogen bonds. Number of hydrogen bonds are increases, their solubility also is going to be increases. Okay, if the solubility is going to be increases means their boiling point temperature also is going to be increases now, because of it forms as a more number of hydrogen bonds. And one more question also. Water molecule can form how many hydrogen bonds, ma? One water molecule. One water molecule it forms as a how many hydrogen bonds? The number of hydrogen bonds formed by one water molecule. The number of hydrogen bonds formed by one water molecule. Tell me, ma. One water molecule it forms as a 4 hydrogen bonds. One water molecule it forms as a 4 hydrogen bonds. Now, if you see clearly means here alcohol it forms as a 3 hydrogen bonds. Aldehyde it forms as a 2 hydrogen bonds only. But if you compare with the ethers also it forms as a 2 hydrogen bonds. But if you compare with the aldehydes and ketones, aldehydes are having strong hydrogen bonding while comparing with the ethers. Okay, so clear. So due to that reason only, alcohols are having high boiling point temperature than that of the aldehydes. Aldehydes are having high boiling point temperature than that of the ethers, and ethers are having high boiling point temperature than that of the hydrocarbons. And one more question. And one more question. So here we have the three types of the alcohols. We have a three types of the alcohols. So what are the three types of the alcohols means here? First, I'm taking as a, I'll give the some structures. Let us see how many members you are going to give the answer. This one. Right now. So which of the alcohol is having the greater the boiling point temperature? I had given first one is called as a N-pentanol. N-pentanol. So this we can call as a isopentanol. This we can call as a neopentanol.
So the first one will have the highest.
First one is having the highest boiling point temperature. Ritu, how you are telling that first one is having the highest boiling point temperature?
Because boiling points of alcohols increases with the increase in number of carbon atoms.
Very good, ma. Simply what we can say means here, if the carbon chain length is increases, okay, their boiling point temperature also is going to be increases. And what is another step we can say means here, surface area is going to be increases. Boiling point temperatures are depends upon the surface area. Boiling point temperatures are depends upon surface area. Surface area. If the surface area is increases, their boiling point temperature also is going to be increases. Okay, so what is the boiling surface area means here? If all carbon atoms are present in a straight chain, if all are present in a straight chain, means their surface area is more. If the branched chains are going to be increases, their surface area is going to be decreases. Okay, if the branched chains are going to be increases means here surface area is going to be decreases. If the surface area is going to be decreases means their boiling point temperature also is going to be decreases. So due to that reason only, N-pentanol is having greater the boiling point temperature than that of the isopentanol. Isopentanol is having greater the boiling point temperature of here neopentanol. Okay, until here clear? Still anyone you having doubts? All of you have got the clarity now?
Yes, sir.
So based on this one, So we have some important concept. Acidic strength. Is alcohols are acidic in nature or basic in nature? Is alcohols are acidic in nature or basic?
Acidic in nature, sir.
Very good one. Either it is the strong acids or weak acids, Samhita.
So I know it's weaker than water.
Okay. So very good one here. So alcohols are weaker than the water. Alcohols are here weaker than the water. Okay. Alcohols are acidic in nature. Alcohols are acidic in nature. Acidic in nature. Acidity is directly proportional to Ka and inversely proportional to pKa, and acidity is directly proportional to electron withdrawing group. Acidity is directly proportional to electron withdrawing group. Electron withdrawing groups and inversely proportional to electron donating group. Acidity is directly proportional to electron withdrawing groups and inversely proportional to electron donating groups. Okay. So did you remember this concept? This concept we already discussed. Where we discussed this concept? Electron displacement reaction, inductive effect and mesomeric effect. There we discussed. Okay. So tomorrow we are going to discuss some of the questions based on this one. So once you revise and come. Okay. Right, ma'am. We'll continue in the next class. We'll continue in tomorrow's class.
Thank you, sir.
So you're welcome.
Yeah.